what I'm going to talk about today is stuff that I've been working on for like the last 2.5 years. But every time I give a talk on it, I get a better sense of like what order to put the material in and how much of it I need to include. So eventually there will be a paper version of this, hopefully sooner rather than later, because I feel like I'm getting to a point where I have a good handle on it. Now, the content is all going to be straightforward and fine. It's just the presentation of it in written fashion that has been slowing me down. But anyway, what I'm going to talk about today stems from a casual remark that was made to me, 2.5 years ago at a workshop in April 2018. I was talking to Frederick Janssen-Larrey, who's, I believe, at Manchester. And we were at a workshop on feminist philosophy and formal logic. And so there was a lot of women there, and we were talking about a lot of women. And we were talking about women in the late 19th and early 20th century, and Christine Ladd Franklin's name came up. And she's somebody that I had heard of. She was a student of Peirce's at Johns Hopkins, did work in Boolean algebra. After her PhD, she moved away from mathematics and more towards psychology, and so she's probably best known for her psychology things. But so she was somebody that was like vaguely familiar with, but didn't know much about. And Janssen-Larrey called her PhD thesis a tour de force, in which, and then I've got a quote of this because it struck me so significantly, that she solved a problem first raised by Aristotle, which had baffled logician for 2,000 years, namely how to reduce all forms of the syllogism to one. Now, as soon as she said that, this immediately caught my attention, because an achievement like this is something that you'd think every logician should know about. And I was rather embarrassed that I didn't know anything about it. Embarrassed on two counts. First, I'm as somebody who is especially outspoken for the need for logicians to be familiar with the history of logic. Here's a historical logician who clearly made an important contribution, and I wasn't familiar with it. But second, I'm also fairly vocal about the position of women in logic, and she is a female logician who had an important historical contribution. And so I did what any self-respecting logician would do, and during the next talk of the workshop, madly Googled her PhD dissertation, found it on Google Books, downloaded it, and then started reading through it. And it's quite long. Well, for a dissertation, it's maybe not long, but for a paper it is. It's a good 70 pages. And reading through it, it took me, I was going through about 2 to 3 pages a day, going through it to see that I could understand, because mathematics and mathematical logic in the 19th century was not written in the same style that we are used to. It doesn't use the same vocabulary, it doesn't use the same symbols. And so I ended up making kind of a commentary of the dissertation, going through, translating everything that she said into something that I understood, in hopes of trying to find what her solution was. And it's this. So I'll give you the quote. The theorem is that the argument of inconsistency, and you can see it's written on in formulaic form, is the single form to which all the 96 valid syllogisms, both universal and particular, may be reduced. And the proof is that any given syllogism is immediately reduced to this form by taking the contradictory of the conclusion, and by seeing that the universal propositions are expressed with a negative copula and the particular propositions with an affirmative copula. Now, if you don't have all of the details of syllogisms at the tip of your fingers, that's okay, we'll come to that in a bit. I want to say something more about the solution, because I found this and was immediately faced with two problems. Not only did I not have any idea what the solution was, I also had no idea what problem it was trying to solve. So that's, the first problem is the one that I mentioned too. It's the one of notation. So not being familiar with 19th century algebra, I didn't even know how to read this. So had to go through all the rest of the dissertation to figure out what the solution means. But the second problem is actually the one that interests me here, which is, what is this supposed to be a solution to? So as presented, both in her own words and in the words of kind of late 20th and early 21st century commentators on her, it was a problem about reducing all forms of syllogism to one form. But the issue is that the idea of form here is confusing, because syllogisms are typically spoken of as having figure and mood, but not form. So the question is, what is the form of a syllogism? Is it figure? Is it mood? Before I talk about that, I will give you your brief digression into syllogisms, just so that we're all on the same page with respect to terminology, format, everything like that. So syllogisms are built out of categorical propositions, which are subject-predicate propositions consisting of a subject term, a predicate term, a quality, and a quantity. So the qualities are affirmative and negative, the quantities are universal and particular, and you can then combine these into 4 different ways to get 4 types of categorical propositions that were recognized by Aristotle. So the A claims, or the universal affirmative, all subject term are predicate term. E, no S is P. I, some S is P. O, some S is not P. In Aristotle, the subject terms S and P are always what medieval logicians would call finite or finitus. So they are kind of concrete bounded terms like man, animal, cat, runs, sleeps, etc. Medieval authors also allow the so-called infinite terms, which are just the complements of the finite ones. So you could reason syllogistically about terms like non-man or non-mortal. So I note this just because it will come up again in a bit. So then a syllogism is a set of 3 categorical propositions which share amongst them 3 terms that each occur exactly twice. 2 of the proposition are the premises and the others the conclusion. The predicate term of the conclusion is designated the major term, and the subject term is the minor term, and then the major term will occur in one of the premises, the minor term in the other, and then the term that occurs only in the premises but not the conclusion is called the middle term. And by convention, we write the premise with the major term first. Note that what I'm presenting to you isn't strictly speaking Aristotle. I'm giving you the Aristotelian syllogism. If we wanted to talk about Aristotle exegesis, we could discuss whether the syllogism is the pair of premises or the pair of premises plus the conclusion, but we're going to look at syllogisms in the sense that Ladd would have been considering these syllogisms at the end of the 19th century. So Aristotle identified 3 figures, or kind of relative arrangements of the major term, minor term, and middle term. Later logicians often added the 4th figure, and syllogisms in this figure are called indirect. So here's just the schematic form of all of the figures. So the way to read this is, in the first figure, the major term, or the predicate of the conclusion, is also the predicate of the major premise, and the middle term is the subject. In the first figure, then, in the minor premise, the middle term is the predicate and the subject term of the conclusion. The middle term is the predicate in the minor premise. The minor term is the subject. And you can see then that each of the figures has a different arrangement of the middle term with respect to the major and the minor. Now, there's gaps here, those underscores, and can be filled in with any one of the 4 copulae. And the result of this is that you get a mood. So you can then reconstruct once you fill in the copulae and you actually instantiate the terms rather than just using the schemas that we have, you get a fully fledged syllogism. So of the possible syllogisms that can be so constructed, these are the ones that I have on screen that are standardly taken to be valid. So again, this is not the ones that you'll find in Aristotle. It's a superset of them, but these are the ones that, on any interpretation of the terms in the premises, will result in a validating interpretation for the conclusion as well. So that's just the background of what we're looking at. And if we go back to the question of what is the form of a syllogism, and we ask, no, because if it were, this wouldn't be a problem that baffled logicians since Aristotle, because it's already well known that, so we've got these 4 different figures. We already knew back in Aristotle that anything in the 2nd or 3rd figure, and later on, once it came into use, the 4th figure, could be reduced to a syllogism in the first figure. This is what the prior analytics is about. So Aristotle provided a mechanism for reducing every non-first figure syllogism into a first figure syllogism, thus reducing all of the figures of the syllogism to one. So this long-standing problem of the form of a syllogism cannot be about the figure of a syllogism, because it's not a problem. We already know how to do that. So what if it's meant, what if we take the form of the syllogism to be the mood? Perhaps then we do have an open question whether it's possible to reduce all syllogistic moods to a single mood. All syllogistic moods to a single mood. Because when Aristotle does the reduction to the first figure, he reduces them to 4 of the first figure ones. So Barbara, Celerant, Dari, and Ferrio, these are the so-called perfect syllogisms whose validity is self-evident and is not in need of further proof. So unlike with the first case where it's not a problem because Aristotle already did it, in the second case, Aristotle didn't do it, but while the question whether it's possible to reduce all the valid moods to a single mood is certainly a question that we can ask, it's also not the right candidate problem here. This is because it's not a question that has exercised logician for millennia. At least if it has, I haven't come across any discussions of it in any of the historical logical texts that I've looked at. I'm gonna say no to that, and I'm gonna do a very brief digression, because some of you might be sitting here thinking about logical hylomorphism, or the idea that arguments, of which syllogisms are, have this form-matter distinction. So this is an idea that developed actually after Aristotle with respect to arguments. So hylomorphism in Aristotle is a metaphysical thing. It's about the metaphysical compositions of objects. It wasn't until about Alexander of Aphrodisias and later that ideas of hylomorphism start getting applied to non-metaphysical things like arguments. So you might be thinking, ooh, if syllogisms have both form and matter, maybe this is the form that we are looking for. But the answer here is, again, no. Alexander, form just, so it's not anything other than that. Later commentators started questioning this, and you start seeing competing views, and kind of by the 14th century, form equals mood. But again, these are the two options that we already had that we had said no to. So it's not form, it's not mood. Is it something else? Well, if it is, I don't really know what it could be. What candidate feature of syllogisms is something that has exercised people in the way that Johnson and Laura's comment about Ladd's solution made it seem like it was. So even in interpreted as something else, I'm still kind of puzzled. So, just to sum up, throughout the commentaries on Aristotle, throughout the Middle Ages that I'm aware of, everybody understood how to reduce things to the first figure, and nobody was particularly interested in reducing them further to a single mood. So that's where we're at. The surprising thing, the reason why I really wanted to kind of delve into this, is that Janssen Loré isn't the only one to speak of Ladd's achievement in the sorts of terms that she used. So probably the most well-known modern commentator on Ladd is Susan Rusanoff, who has this to say, so I've added emphasis, but she says, in 1883, Christine Ladd Franklin published a paper titled On the Algebra of Logic, in which she develops an elegant and powerful test for the validity of syllogisms that constitutes the most significant advance in syllogistic logic in 2,000 years. In this paper, I bring to light the important work of Ladd Franklin so that she is justly credited with having solved a problem over 2 millennia old. And later commentators on Ladd, drawing usually quite heavily on Rusanoff, echo similar sentiments. So I've got interestingly, a paper by Pietainen where the preprint version and the published version don't match. So the preprint says that the result of LADS was a groundbreaking discovery involving the reduction of Aristotelian syllogistics. The published version has reduced this to simply the result was the reduction of Aristotelian syllogistics. So I'm not sure what happened during the reviewing stage, but something did to cause him to temper his analysis of the contribution. But he also says, again, quoting Rusanoff, Lad Franklin in fact managed to solve, or at least to see the solution to, the problem that was over 2 millennia old, though she did not give, nor could she have given the proof in such a rigorous form that is possible nowadays in the semantic terms of possible interpretations of varying domains. So he, even if he had kind of tempered So clearly Lad achieved something important. It's just not clear what. So I would like to turn from the question of what the problem was to the question of what is her solution. Because maybe if we understand the solution, we can figure out what problem it was solving. So, yes, everybody assumes that we know what this problem is. Nobody ever actually says in what I've been able to find. So going back to the content of her PhD, she is interested in, as the title said, algebras of logic, and she identified 5 different algebras of logic that were in contemporary currency at the time, due to Boole, Jevons, Schroeder, McCall, and Peirce. And her attempt was to introduce a 6th that addresses some of the drawbacks that she sees in the previous attempts. So the latter 4, Jevons, Schroeder, McCall, and Peirce are all variations, she says more or less slight, of Boole's. And in much the same way, Lads herself is going to be not a radical departure, but just basically a changing of the notation so that you can express things more concisely and more elegantly. So I'm going to work through what is necessary in the content of her dissertation in order to actually be able to understand the slide that we started off with. The basic component of Lad's algebras are subject and predicate terms, same things that we saw in the syllogistics. So atomic subject and predicate terms are indicated by lowercase letters A, B, and C, and Lad also follows Wundt and Peirce in using the infinity symbol to represent the domain of discourse. So that's just the term that picks out everything. If you've got your set of atomic terms, you can then form complex terms with negation, conjunction, and disjunction. She uses the bar above, multiplication and addition for these. And because you can drop the multiplication symbol, you can just write what is both A and B as AB. She's also allowing infinite series of plus and times, and the complement of infinity is 0. It's the domain that has nothing. So all fairly straightforward. There are 3 things that can be done with these terms. The identity of the subject and predicate terms can be affirmed. The identity of the subject and predicate terms can be denied. And complex terms can be negated. So what we have, you can take an atomic term and form a negation of it, but this doesn't immediately tell you how to make the negation of a complex term. And Lad identifies 3 different ways, one due to Boole and Jevons, one to De Morgan, one to Schroeder. The details actually don't matter for our purposes, so I'm going to skip them here and say a bit more about actually the identity and non-identity propositions. So there's 2 types, those which affirm the identity and those which do not. In all 6 of the algebras under consideration, the original 5 plus Lads, they are all expressed in the same way by equality. So it's important that while Lad uses A and B to indicate this general way of indicating identity, identity propositions are not restricted to atomic terms. You can also use complex terms. So this is one of the things which makes it basically impossible to just open up her dissertation, find the relevant page where the theorem is discussed, read it, and understand what's going on. Because there's this slippage between A and B as picking out atomic terms, and A and B as essentially metalinguistic variables for any terms. So there's a number of different true identity propositions involving positive terms that you can introduce. Their identity and, addition and multiplication are idempotent, associative, commutative. They distribute over each other, so things work in the way that we expect them to work. But identity should not be understood as the identification of two objects picked out by a constants in some logical language, but rather as indicating intersubstitutability of the logical expressions, salva veritate. So she says explicitly that the proposition A equals B is equivalent to the two propositions, there is no A which is not B, and there is no B which is not A. So this is another difficulty that you sometimes run into reading her work. There is not a fixed distinction between kind of object language and meta language. And so she is perfectly willing to say that you've got this A equals B proposition being completely equivalent to this English language proposition, and she will use them interchangeably with each other. So Ladd's result is about syllogisms, and therefore we need to find a way of representing types of categorical propositions in this Boolean algebra. A equals B only gives us coextensiveness. It doesn't give us the quality-quantity relationship between a subject and a predicate. Ladd says that there are two ways that we can do this. We can either assign the expression of the quantity of propositions to the copula, so the thing that links the subject and predicate, or to the subject. Just a moment. I need to keep him from interrupting me. If quantity is assigned to the copula, then you need to have two copulae, one universal and one partial. And this is the route that McCall and Peirce take in their algebras. If it is assigned to the subject term, then only one copula is needed, and that's going to be identity. And this is the route that Boole, Schroeder, and Jevons take. So here is a summary of the different ways that you can represent the different categorical propositions in each of the 5 algebras that Ladd is starting from. So in the Boole-Schroeder version, V is not a categorical term like A and B, but it's just a term that picks out an arbitrary indefinite class. Jevons C works similarly, but he doesn't distinguish it in the way that Boole and Schroeder distinguish their V. It's just any other class term. So could be just cats. The question is, which of these two ways is preferable? So an advantage of the Boole-Schroeder-Jevons approach is that only one copula is necessary. So you have a limited language, but quite a lot of expressive power. On the other hand, the advantages of the McCall-Peirce way is that copulas that include their quantity can be used to link either terms or propositions. So we could use one and the same language to say either A is not wholly contained under B, or A does not imply B. So in the first, we've got a linkage between terms, and in the second, we have a linkage between propositions. She also notes that an advantage of the McCall-Peirce route is that there's a correspondence between the quantity of the copula and its quality. So the universal copulas are positive or affirmative, and the partial copulas are negative. So you can see that here, that if you look at the McCall and Peirce columns, you've got affirmative copulae in the universals and negative copulae in the partials. And then the actual quality comes from the combination of the quality of the copula and the quality of the predicate term. So that's also a nice correspondence to have. Ladd's contribution in her paper is to introduce another way of doing this. So she introduces a new copula that's going to be wholly symmetric. So the other ones are not necessarily symmetric because of this because, you know, A is not wholly contained under B is not the same as B is not wholly contained under A. So she's going to keep the two copula situation, but reverse the qualities of the two copulae. So instead of taking as basic, essentially the A claims and the O claims, she will take as basic the E claims and I claims. So we have essentially A disjunction B is A is partly B, some A is B, and A disjunction bar B is A is wholly not B, or no A is B. In her new language, then, we can represent the four Aristotelian categorical propositions, but we can also represent all of the 8 types of propositions that De Morgan mentioned. So it's because we've got the positive and the negative copulae, and we've got 2 terms which can either be negated or not negated. So just to show the expressive power of what she's introducing. So both V and V bar are symmetric combinators. They can be read either forward or backwards, and this is in contrast with the inclusion statements using the kind of the Y bar arrow, I don't remember what it's called in LaTeX, which are asymmetric. There's a correspondence between the two, of course, in that you can convert inclusions into exclusions by changing the copula and the sign of the predicate. So A inclusion B is going to be the same as A V bar B bar. And every exclusion is equivalent to a pair of inclusions, depending on which of the 2 terms you take as the predicate. Because if you start with an exclusion and it's symmetric, you can either form an inclusion that has A as the predicate or as B as the predicate. So these are illustrated here. So the advantages of this approach is that categorical statements and hypotheticals are treated identically in the formal system. So it doesn't matter if we're talking about relationships between terms or relationships between propositions, it's all handled in a uniform fashion. In particular, if we let P denote some premise and C conclusion following from P, then we could express the fact that C follows from P either as P V bar C bar or C V bar P. Both of these are read that P and not C are inconsistent with each other. It's probably the most straightforward to see it. So we've got the symmetry again. Mutual inconsistency doesn't have the same sort of directionality that implication does, and so it might be more straightforward to think of inference in this non-directional sense as merely stating the mutual inconsistency of the premises with the negation of the conclusion, rather than as this sort of direction. When you do it in this symmetric fashion, you're just kind of stating the fact of their inconsistency. With that, we can now say quite a lot of things. We can express existence and non-existence claims using the infinity symbol, the domain symbol. So x v bar infinity basically says there are no x's, and x v infinity says there's at least one x. And because we can translate between propositions and terms, we can just drop reference to the domain of discourse if we need to, because we can always restore it without there being any ambiguity. So instead of writing x v bar infinity, we can just write x v bar to say there are no x's, and x v to say that there are x's. So then we can translate categorical statements, such as no A is B, into statements about terms, namely the combination AB does not exist. So this is another advantage of her approach. Okay, this was roughly 20 slides of background, so that hopefully you have an understanding of the sorts of approach that she was doing, the context she was working in, and the notation that she has. So I've skipped a lot of background, and one of the difficulties that I've had kind of giving this talk or working on the paper is figuring out how much of the background material I need to put in and how much I can just skip over because it's not on topic for this specific thing. But I believe that you've got enough now that we can move on to talking about what Ladd sees as the three main subjects of logic. So these are why she's developing this system in the first place, is because this is what symbolic logic is interested in. So from a historical, sociological point of view, this is really interesting because it's not necessarily what we would say is the subject of logic in the 20th century or 21st century. So the three main subjects for any symbolic logic are the uniting and separating of propositions, the insertion or omission of terms, or as she calls it, immediate inference, or elimination with the least possible loss of content, or syllogism. Of these three, it's the third that we are interested in. And why is syllogism the elimination of terms? Well, consider the premises of a basic syllogism like Barbara. So all cats are animals, or all cats are mammals, all mammals are animals, therefore all cats are animals. Between the two propositions, there are three terms, cat, mammal, and animal, one of which occurs in both of the premises. And if you look at the conclusion, that term is the one that's been eliminated. So the middle term links up the other two terms and then disappears by the time we get to the conclusion. So the most common object in reasoning, Ladd says, is to eliminate a single term at a time, namely one which occurs in both premises. And she says that the goal of this goal of logic can be accomplished via the inference from if A is B and C is D, then AC is BD. So that is what is depicted in proposition 1. If we take term D, because you'll notice that formula 1 there has 4 terms in it. So this isn't a representation of a syllogism because syllogisms only have 3. But we can get rid of D by just setting it to being the complement of B. So now we're back to 3 kind of atomic terms, whether some are negated or not, doesn't matter. And then we have that B plus D, i.e. B plus B bar, just is infinity. So we can rewrite the proposition 1 as proposition 2, and we can read this as the combination of no B is A, all C are B, some A is C, is inconsistent. So we are now getting very close to the main result, the one that got us going in the first place. Formula 2 is asserting the inconsistency of these 3 propositions. That is, if you take 2 of them, you then have to take the negation of the other one. Whichever 2 you take, you will eventually eliminate one of the terms. So an interesting thing about this particular form, and this goes back to the fact that these are not directional, is you can pick any pair. So take any 2 and the negation of the last, and you'll have a good argument. So Ladd's theorem is that every valid syllogism can be reduced to this particular statement of trifold inconsistency. So now we're back to the slide we started with. We've got the argument of inconsistency, and now we understand how to read it. So no A is B, or that no A is B, that all C are B, and some A is C are all inconsistent with each other. So from this theorem, a corollary follows in the form of a very easy to apply rule stated in ordinary English for identifying whether any syllogism is valid. Take the contradictory of the conclusion, see that the universal propositions are expressed with a negative copula and the particular propositions with an affirmative copula. If 2 of the propositions are universal and the other particular, and if that term only, which is common to the 2, has unlike signs, then and only then the syllogism is valid. And it is possible to check that this will generate the same list of valid syllogisms as a lot of the other systems of identifying valid syllogisms, such as distribution of terms, or the medieval dictum de omni and dictum de nullo. But she's, via this one particular representation of the syllogism, she's been able to turn it into kind of a single test. So let's look at some examples. Let's actually do some syllogisms. We have the syllogism Barocco, which says that all P is M, some S is not M, therefore some S is not P. This is equivalent to the inconsistency that I've put down at the bottom. I won't read it out because it says the same thing. And the syllogism Boccardo, which is some M is not P, all M is S, some S is not P, is equivalent to the inconsistency that's written here. And what you will see is that these are, how do I want to say it? This particular method of taking the contradictory of the conclusion and kind of adding it to the set of the premises, the rudiments of this sort of approach is exactly what Aristotle is doing in his reductions. And this is actually something that Katzoff noted in 1936. So he was commentating on Ladd's contribution, and he says that this method is actually the method of indirect reduction, which is denoted by the letter K in the mnemonic names Barocco and Boccardo. Side note, usually that's C. I don't know why Katzoff thought it was K. And the name anti-logism was given to this by Mrs. Ladd Franklin. So the rudiments of Ladd's solution are already in the Aristotelian reductions. So just to make this more explicit, Aristotle reduced both Barocco and Boccardo to the first figure syllogism Barbara via the method of reductio ad absurdum, which is take the contradictory of the conclusion, replace one of the premises with it, and then the premise that you replaced, take the contradictory of that and make it the conclusion. So in both cases, if you take the contradictory of some S is not P, you get all S are P. Swap that for the partial premise and take the contradictory of the partial premise, make that the conclusion, rewrite your terms so that you've got your middle, your minor, and your major all in the right place, and you get Barbara. It's interesting that it's only Barocco and Boccardo that Aristotle used this method for. For all of the other ones, he was able to give a direct reduction to a first figure syllogism as opposed to needing to do this indirect reduction. So I want to say something about how what Ladd is doing differs from the Aristotelian approach. So Aristotle took Barbara as basic and reduced Barocco and Boccardo to it. Instead of that, what Ladd did was show that one can take as basic the general inconsistency of the three claims, all M are P, all S are M, not all S are P. So take any two of these propositions, it entails the denial of the third, which is to say that the contradictory of any of the propositions follows from the other two. And that gives us all three syllogisms, Barocco, Boccardo, and Barbara. So this is the sense in which these three syllogisms are reduced to one form. So what's the benefit of doing this? Why do it Ladd's way rather than Aristotle's? So Ladd says, if for the usual three statements consisting of two premises and a conclusion, one substitutes the equivalent three statements that are together incompatible, one has a formula which has this great advantage. The order of the statements is immaterial. The relation is perfectly symmetrical. So it goes back to the reasons why she wanted to have the symmetrical copula in the first place. Excuse me. In addition to the symmetry of the relation, the result is a source of great simplicity. There's only one valid form of the anti-logism instead of 15 valid forms of the syllogism, which common logic requires us to bear in mind, or 24 if you're going to allow some of the subalternation because of existential import. Thirdly, both the simplicity and the symmetry can be improved upon if all three of the claims are written as either E claims or I claims. So reducing everything to one of the basic ones. And this is possible if we admit infinite terms. So all S are non-P, so that's an A claim, is equivalent to no S is P. And some S is not P is again going to be equivalent to some S is non-P. So this is something that Reichenbach discusses in 1952. At this point, he says that Aristotle does not refer to these forms in his discussion of the syllogism in the Analytics. This seems never had to have been corrected until modern times. So I just want to put a brief note in here to say this is categorically false. The use of infinite terms was routine in medieval logic, which is why I mentioned them earlier in the talk. Now, this is something that Reichenbach was probably not aware of, but it just goes to show that you shouldn't state that something hasn't been done before modern times if you aren't actually familiar with what historical logicians did. So, huge tour through 19th century Boolean algebras. We now have an idea of what she did. But this is only the first step to seeing what problem it is that this solves. So I want to do something that I haven't seen other modern commentators do, which is look at, well, what did Ladd herself say she was doing? It's quite clear that she didn't think she was solving a problem of Aristotle. She hardly refers to Aristotle at all. I think his name shows up twice in her dissertation, and they are both entirely throwaway remarks. What she thought she was doing was solving a problem of Jevons. So her algebra, she says, contains a solution of what Mr. Jevons calls the inverse logical problem. So in one place in 1880, Jevons describes this problem as given certain combinations inconsistent with conditions, determine what those conditions are. So you've got combinations of terms or of propositions, and they're under certain conditions, they are inconsistent. Find out which conditions those are. That's the problem. So a more precise characterization is given actually earlier in 1874. He says, 3 terms and their negatives may be combined in 8 different combinations, and the effects of laws or logical conditions is to destroy any one or more of these combinations. Now, we may make selections from 8 things in 2 to the 8 or 256 ways, so that we have no less than 256 different cases to treat. And the complete solution is at least 50 times as troublesome as with 2 terms. The test of inconsistency is that each of the letters, capital A, B, and C, lowercase a, B, and C. So just to say about Jevons notation, the capital letters stand for kind of the presence or the existence of things that are A. The lowercase ones stand for absences. The test of inconsistency is that each of these letters shall appear somewhere in the series of combinations, but I have not been able to discover any mode of calculating the number of cases in which inconsistency would happen. An exhaustive examination of the combinations in detail is the only method applicable. This sounds excessively tedious. So the solution that he gives consists in inventing laws and trying whether the results agree with those before us. So trial and error. This is not going to be very acceptable, and both Schroeder and Boole also tried to solve the problem. So in a later text, not her 83 dissertation, Ladd says that the task which Boole accomplished was the complete solution of the problem, given any number of statements involving any number of terms mixed up indiscriminately in the subjects and predicates, to eliminate certain of those terms, that is, to see exactly what statements amount to irrespective of them, and then to manipulate the remaining statements so that they shall read as a description of a certain other chosen term or terms standing by itself in a subject or predicate. So the difficulty in Boole's solution is determining what are the terms or terms to be eliminated. Once you've identified the term, as Ladd says, an ordinary syllogism would be suffice to put it to flight. So while Boole's rule gets the conclusion right, she's critical of it. She quotes Venn, who says that Boole's method was a terribly long process, more theoretical than practical. Secondly, she says that Boole's form of the conclusion would have to be altered to fit the notation of her algebra and is also not natural or frequently useful. And she has kind of external reasons for criticizing the approach that Boole takes to the formulation of the conclusion, says it's suited only to a logic of extension and doesn't work well under an intensive interpretation. So that should say intensive, not intensively. So the problem that Jevons had, he solved by saying, okay, brute force, trial and error. Boole came along, gave something slightly more sophisticated, but Ladd has a number of criticisms of it, and in comes her solution. So how do we get from what Ladd thought she was doing to this idea of Rusanoff and Pietainen that Ladd solved this millennia-old problem and that this was a problem of Aristotle? So I've got two more quotes here that I really take issue with. First, she says the problem that Aristotle posed and attempted to solve is to give a general characterization of the valid syllogisms, but she doesn't give any evidence that this corresponds to the problem that Ladd was solving. And she also says he did not succeed in providing a unified and complete treatment of the syllogistic argument. One might also ask, why would we think that he wanted to do this or intended to do this or thought he had to do this? So again, it's not entirely clear that the problem that Rusanoff has identified is something that would have been a problem for Aristotle. One could also object to this characterization of Aristotle's results, because in a sense, he did provide a unified and complete treatment. He introduced conversion rules, showed how to reduce all of the valid ones to the first figure syllogisms, and he gave meta-proofs to show why the other ones are invalid, that no reduction could be given to them. So anyway, at this point, I've read through this massively dense and foreign dissertation, and I've looked at all of these people lauding the solution, and I found myself at this point kind of mired in a pit of metaphysical despair. So as I'm doing logic with like symbols and proofs and everything, I found myself asking questions such as, what counts as a problem? Does a problem have to be recognized as a problem for it to be a problem? Did the problem that Ladd solved exist through 2 millennia in which no one was bothered by it? So does a problem have to be problematic for somebody? So these are difficult questions to find yourself being faced with, and at this point, I became really interested in trying to figure out how the story developed that got us to a point where I was asking these questions. I wanted to know that more than actually answering these questions. Now, let there be no doubt. Ladd definitely articulated in a symbolic language a result that had never been done before in such precision. She was not reinventing the wheel, even if all of the various little bits may have been present. She was the first person to actually put them together. But at some point between 1883, the publication of her dissertation, and 1999, when Rusanoff published her seminal work on it, our perception of what she did changed rather drastically. And in the last bit of time that I have, let's see where we're at. Yeah, this is working out quite nicely. I want to say a little bit about why and how this happened. So, a bit of historiography. In the earliest review of Ladd's paper, so shortly after it first came out, no mention is made of this result. The unidentified reviewer, it was an anonymous paper. I have no idea who wrote it. Don't think we ever will. introduces Ladd's notation, gives it semantics and formation rules, and notes that with these, she's able to write algebraically all the old forms of statement and to perform the customary operations of symbolic logic with great brevity and facility. The singling out of the anti-logism, so this is the name that later became attached to this argument from inconsistency. So as far as I can tell, the first person to single this out as a fundamental contribution was by Brown in 1909. So when Miss Ladd Franklin has demonstrated that one simple form underlies all syllogism. So he was the one who kind of picked that out as being worthy of note. So this, 1909, that's about 16 years after her dissertation. But something happened by the 1920s. So in 1927, Shen quotes the late Professor Josiah Royce of Harvard. Says there's no reason why this should not be accepted as the definitive solution of the problem of the reduction of syllogisms. It's rather remarkable that the crowning activity in a field worked over since the days of Aristotle should be the achievement of an American woman. It both amuses me and makes me angry to have to read sentences like that. So, Shen, of course, doesn't say where he got these words of Professor Josiah Royce of Harvard, but Spillman in 2012 did some of the archival work and has this quote from Royce that we saw, and this is from the New York Evening Post. And it appears that this comes from newspaper articles roughly around 1926, 1927, which is the time when Ladd actually received her PhD. So she wrote her dissertation in 83, fulfilled all of the requirements for a PhD in mathematics at Johns Hopkins, but wasn't allowed to actually get the degree because she was a woman. And this wasn't rectified until 44 years later, at which time you then have kind of popular news articles about this woman who's finally getting her PhD in mathematics and should have gotten it years ago. So there's also a citation here to the Hartford Courant from 1926. So this is where this idea has come from, as far as I can tell. And if you look at the quote, there are two pieces of information. One, this is a definitive solution to the problem of the reduction of syllogisms. Two, this is the crowning activity in a field worked over since the days of Aristotle. Both of these can be independently true without it being the case that the problem itself has been worked over since the days of Aristotle. So I want to sum up with some concluding remarks, looking at kind of the history of how all of this went. In her 1883 dissertation, Christine Ladd Franklin introduced to Boolean algebra a pair of symmetric copulae. This allowed her to define the anti-logism, which is an inconsistent triad that could be used to represent every valid syllogism. People recognized the utility of this representation soon after her work in the 86 review, and then in the paper from 1909, where the particular utility of the anti-logism is specified. Within 30 years or so of the dissertation being published, people made the leap to her formula being a solution to a problem. And within 40 years, people attributed that problem to Aristotle. At some point then, between the 20s and the 90s, the problem that was attributed to Aristotle got imputed to all of the intervening logicians as well. So while she solved a problem, I would like to argue it wasn't Aristotle's, and it hadn't vexed people for millennia. Instead, the problem that she solved was due to Jevons, and it was something that both Schroeder and Boole had attempted to solve, but she was able to give a much simpler and more elegant solution to it. So kind of the end result of all of this, the take-home message that I want you to have is that, yes, what Ladd did was pretty awesome, and she should rightfully be credited with the contribution that she made. To describe it as the solution of a millennia-old problem doesn't give it, does it a disservice. It's not. But that doesn't mean that it wasn't a groundbreaking and seminal result that we should, I think more people should be familiar with in the details and how it came about than perhaps are. So I've actually got 3 pages of bibliography here, but since the slides have been made available, you can browse that at your leisure, and I will end here by saying thank you.